Hello, everyone. Welcome to our SAP Community Call about Get From Zero to Production with SAP Cloud SDK. We have today with us Jordan Dukadinov, who's a developer advocate for the SAP Cloud SDK team. Jordan, please take it away.
Thank you, Moshe. Hello and welcome from me as well. As Moshe said, I'm Jordan from the Cloud SDK team. So today I want to show you how to quickly create a project and get it from a bootstrap application up to production. For this, we will use the command line interface of the Cloud SDK and some other tools. As usual, I want to emphasize that I'm not doing any official announcements today, so always make your decisions based on what's available today. Okay, the agenda of today's call. Before we move on to the announced topic in the title, I'll provide a brief overview about what's new in the Cloud SDK, and then we move on to a small demo about how to set up a project using the command line interface of the Cloud SDK. And last but not least, I will ask you to comment on the chat or later on the recording comment section about the topic that I'll show in a minute in the What's New section. Having said this, let's directly jump into the What's New section. But before that, I want to briefly remind you what the Cloud SDK does. And for those of you who may join us for the first time, just to get a high-level understanding what we do. So what we see on this picture is high-level architecture of an cloud application, which might run on the SAP Cloud Platform, like we see in the center of the screen. And here we see the Cloud SDK doing two functions. One is it helps developers to consume SAP Cloud Platform services or APIs and endpoints from other SAP products, like on the left-hand side, like we see here, S/4HANA, SuccessFactors, Concur, and others. Having a look to the right, we see that the Cloud SDK also provides continuous delivery functionality, which helps us to achieve very high speed, high degree of automation, and after all, deployment without downtime. This was a very brief introduction of what we do. Having a look at this picture, also very short, here we see an example how the Cloud SDK can help. In this picture, we see the S/4HANA extensibility patterns, which might be either in-app extensibility, like on the left-hand side, meaning that we do our extension code and all the changes inside of S/4HANA. This is what's known as classic extensibility, like most of our customers and partners do it. And on the right-hand side, we see the SAP Cloud Platform that might be another pattern to extend S/4HANA, meaning that we build a small application on the SAP Cloud Platform that's actually the extension to S/4HANA. And this small application on the right-hand side is powered by the Cloud SDK, runs in the SAP Cloud Platform, and thus brings all cloud native qualities. In the same time, it's very good integrated with the business processes running on S/4HANA. So this is a very short introduction of the Cloud SDK. And now let's have a look on what we did since our last call. On this slide, we see the highlights for Java and JavaScript. I'll start from the top with the Java part. The biggest highlight and something that we worked very hard is to provide preview support for OData v4. With our final last release from last week, we added new libraries for OData v4, and at this point I want to emphasize that they are still beta, so feel free to use them and to try out, but keep in mind that APIs might change. Then, as we know, S4HANA provided a new release, the 2002 release in February, and thus we updated our clients for Java and JavaScript for the new APIs that S4HANA Cloud Edition delivered. And here again, I want to encourage all of you that are still using the Cloud SDK for Java version 2 to upgrade to the version 3, because version 2 runs end of life soon, and we'll stop providing updates for the version 2. On the JavaScript side, we also worked a lot on improving the proxy configuration support. Yes, even in cloud applications, we sometimes need proxy for different scenarios. For example, when accessing on-premise systems. So we worked to support the standard environment variables, for example, so that they get considered when running the apps. And as I already mentioned, OData v4 is our biggest highlight and what is keeping us busy at the moment. That's why I want to provide a short deep dive into this topic. So the OData v4 support that we released as preview, like already mentioned, consists of a few Maven artifacts like we see here. The most important part is, of course, the first one, which is OData v4 core, and the second section, which is the generator section, shows that we also released a generator for OData clients, which can be used either as command line interface or Maven plugin. All of these libraries are available on Maven Central and can be regularly included into your Maven build. Usage of OData v4 is very similar like OData v2, and that you probably are used to. So having a look at this example test method here, we see that the pattern how we invoke a service is quite similar. At this point, for example, we see the line with the filter that already includes some advanced functionality that's only supported in OData v4. And this is also an example of the first thing that you can use with our preview version. So here we see that we can do advanced filtering functions depending on the property type. This is only one of the few things that we added, and we hope that we'll get a final OData v4 support soon. Yes, here is a point where we ask you for your feedback. So we are interested in, are you using OData v2 or v4 in your project? And of course, what is your experience with OData v4? Or do you have something that you missed? So if you have some input for us, then please provide us either in the chat or in the comment section below. All right, this was a small recap of what happened in the last month. And now we move on to the announced title, which is From Zero to Production. And what we'll do today is we'll bootstrap a new project and show how to get this project into a productive state. Like shown here, it's safe to try everything from this session at home. Everything is open source or available as trial accounts. Like we see, what we'll use today is the SAP Cloud Platform account, which can be subscribed as trial, which is free. A Git server, for example, GitHub or any other server, and the local Docker installation. And of course, the Cloud SDK, which we will consume from the two repositories shown here. All right. Before we jump into the demo part, let's think about how a developer starts a project. So usually we decide to start a project and we think about, okay, let's get an example that is running. Let's try it out and see what happens if we get it running, so that we can learn how it works and do some modifications. And this is exactly what we will do. I'll jump back to the last slide, just that everyone can follow. So first thing we'll do is we'll check the first repository here, which is the Cloud SDK CLI. I'm clicking the link, and here we see it's open source. Everyone can see the code and also propose changes. If we scroll down to the documentation part, we see that the Cloud SDK CLI supports a few things, which we call commands. And here we see that we have different commands like add app router, add CDS, add CX server, but also going towards the bottom, we have init and package, among others. So what we see here, we have commands for one, for starting a new project, which we will do in a second, but also two, if you already have a project that you have programmed and that is running, you can also use the CLI to simply add app router or add CDS support. But today, let's go the simple part, which is the init part. And before we can use the CLI, we of course have to install it. And this is also described in this README. And this is the first thing that we will do. Like we see here, the beginning of the page, we can consume the CLI regularly using npm. So it's also published here, which means that this is what I will do now. So I'm starting in an empty directory called workspace. And right now I will not do the installation like here, because if I do this, I will install this globally on my machine. But for the sake of this demo, I will only install it locally. So I will not only paste this line here, but remove the -G. So I have a pretty good internet connection, so don't wonder if it's slower when you try this. Right now I've installed the CLI, and what we see is that it created node modules and package log.json. Now I'm ready to use it. And since I installed it locally, I can't just invoke it in a way like here, like the commands say, that I have to use npx, which is pretty common and well known in the Node.js community. I'll explain what it does in a second. Like I said, if I try to execute this one, it won't work. Let's go the application that I'm creating my app. And what I'll do now is use npx, which is also a Node.js program that actually looks for binaries inside of the current directory, which is here, workspace / node modules. And right now I see that the Cloud SDK CLI is already running. And for sake of the demo, I'll stay with the defaults everywhere. What's happening in the background is not only an npm init, but also some more things that prepare the project to be runnable. Let's wait a second for it to finish. Project name, I'll stick with the same name like I already provided for the directory. And we don't want to provide analytics. And here we already see that some interesting things happen. It's not only generating the project, but it's also adding some default dependencies to package.json. We'll have a look at them in a minute. It's also doing an install so that the output of this process will be runnable right away. And it's also generating git ignore so that we can directly deploy it to GitHub or to whatever Git server we want. All right, now we're finished. And if we have a look at the directory, we see that it generated my app here. Let's switch to my app. And here we see a pretty common layout of a Node.js application with package.json and everything else. And to be more convenient, I'll move on to Visual Studio Code, for example. Of course, at this point, you can use your IDE for your choice. And what I will do now is I'll open this directory, my app that we just generated. So here, you remember we started with empty workspace and generated my app. All right, and here on the left, we already see the structure of the project that was just generated. Let's have a quick look at the package.json. All right, we see that it generated the app called my app in version 001. There is a bunch of scripts here that got also generated for us. It's not only a build script that we can use for building the app, of course, test and start, but having a look at the bottom here, we also see that we have some scripts for example, deploy, CI build, CI package, and so on. And like the names already suggest, we can use these scripts to do very cool things. Let's have a look at the code. We have a few TypeScript files, and what this app does is, guess what, hello world, and that runs on localhost port 3000. And like I already mentioned, the Cloud SDK CLI not only generated all this content, but also did an npm install. We can see that here the node modules directory is already filled with content, which means that I'm able to run this app right away. And to do so, I'll start the terminal here. I am already in my app directory, so I can simply do npm start. I didn't have to do npm install in this case. Pretty convenient, and yeah, like we see, Nest application is already running. And if I go to a web browser here, we can invoke localhost 3000, and we see that the app is up and running. All right, this was the first part of the demo. We are all developers, so we know that if we make this, then we are quite happy. So now we were able to init a new application and to build it, and we tried out that it actually worked. In the next step, of course, we want to try out if our new application also is deployable and runnable in the cloud. And this is also something that the Cloud SDK CLI supports. And this is also something that's very convenient. To show this, I'll switch again to VS Code. And we'll have a look at the package JSON again. So, of course, we could pretend that we are a CI server and execute the scripts here, but in this case, we don't need to do so because we have this deploy script here, which implicitly invokes a CI build and CI package, and also does a CF push here. So that, in fact, I'm able to deploy to the cloud by simply invoking this script here, which is the deploy script. And let's do so. So I'm invoking npm run deploy. If I start this, we see that it started with CI build here, and CI package. And after the package phase is ready, it will start to do the CF push. And for those of you who didn't try Cloud Foundry yet, CF is the local client for Cloud Foundry. This is actually the C is for Cloud and F is for Foundry. And here in the terminal, we see that it already does the upload. While this is running, I want to show you how Cloud Foundry works. This is a very brief demo, or not demo, but explanation. This is the Cloud Foundry documentation page here. And I want to briefly show this picture. So if we have a look at the middle, which is IaaS, infrastructure as a service, and this might be anything from AWS, Azure, Google Cloud, Alibaba, or any other vendor, which is only providing infrastructure, meaning, for example, Linux systems. And what Cloud Foundry does is, if we have a look at the right, we see that Cloud Foundry is adding middleware and runtime on top of what the infrastructure as a service provides. And this middleware and runtime is packed into so-called build packs for Cloud Foundry. And they are available for Node.js in this case, so that we, in fact, only upload the Node.js script, but not the Node.js runtime itself. That's why after we upload the Node.js script, the platform needs some time to configure the runtime and do an npm install and all the other things. While I explained this, we see that the deployment is finished, and the cloud platform provides me this URL here, which I can invoke in my browser. So let's open a new tab. And like we see here, the application is deployed. And right now, I created a deployment on Cloud Foundry. And I can also have a look here. If I say CF apps, I see that I have deployed my app, one instance with this memory. And this is the URL that we already tried out. And there is one piece missing, how all of this works together, which we can see if we have a look at the generated files in the manifest.yaml file, which is this one. So here we see a few things. First of all, we see that we are deploying one application, which is my app. It's the same like here below in the console. Then we see that what we upload is located here under the development subdirectory, which is here in the project structure. I already mentioned the build packs. We see that We are using the Node.js buildback. Again, this is the runtime that the cloud platform provides for our application to run. We can define how much memory we want. And last but not least, we define how our application should be invoked by the platform. We can also define many other things here, but these are the very basic ones. So you see that actually after we did the upload, and the platform used this buildback to provide the runtime and then use this command to start our application. And after all of these things here finished, we got a response, this long URL here, which got generated by the platform because we defined here that we want a random route. So here we could also define our own route. This is the very basic introduction on how the platform works with all this information that we provide here. All right, now we are in the cloud and back to here. Okay, what have we done now? We've generated a new application. We see that it runs locally, which was our first success. And our second success was that we were able to deploy this to Cloud Foundry, SAP Cloud Platform. And now we start thinking about the next step. The next step would be automate. This is something that we recommend to be considered at the beginning of a project. Even before real development starts, we recommend you to at least think about how to automate deployment and how to handle code changes. And this is an example of what might be possible here. We write code, then we push it to some Git server, for example, GitHub. And then we have a continuous delivery process, like these green dots here. We'll have a look in more detail in a second. And then, of course, we want to have automated deployments and, if possible, without downtime. That's the goal because, after all, we want our users to not get interrupted when we do when we deploy updates for our application. In order to get this running, I'll do some more things. Briefly, I'll show this slide again, and we'll have a look at the last link here, which will take us to Cloud S4 SDK pipeline. So I'm clicking this link as well. Like mentioned, this is all open source and can be consumed by anyone, so that you can try out everything that you see in today's demo. What this repository is doing, like the name already suggests, it contains a continuous delivery pipeline. And the continuous delivery pipeline is always constructed out of two components. The one component is the pipeline configuration, and the second component is the pipeline infrastructure. Let's start with the pipeline configuration. If we have a look at the generated project here, we see that we find things like a Jenkins file here, but also here a subdirectory, which is S4HANA pipeline with some things and some other artifacts. And this is actually what we call configuration as code. So this is these are artifacts that are actually generated for your continuous delivery pipeline. And you can do your configuration here next to the program code, like we see. Here is the business code, business logic. And you can also commit your continuous delivery configuration to GitHub. This is very valuable because the goal is when you configure your continuous delivery pipeline, the goal is for it to be reproducible so that you can easily move it to another infrastructure or easily rerun something that maybe went wrong and debug and look for what's going on. And this is the first component of the continuous delivery pipeline. We actually got it here, generated by the Cloud SDK CLI. In order to get this running, we need the second component, which is the infrastructure. And for this, we have different options. Like this Jenkins file suggests here, we can use a Jenkins server. And in fact, we are free to use any Jenkins server that we have. But if we don't have one, we have either the possibility to host one online, or we have the possibility to run our own Jenkins server inside of a Docker image. So for example, if I have a server capable of hosting Docker containers and running them, then I can use the content of this repository to generate my Docker container and to make it run my Jenkins server. And in order to do so, I can show how it works locally. I click this doc directory, which is for documentation, and then I follow this link here. Because meanwhile, the documentation for the continuous delivery pipeline is moved to this page here, which is Project Piper. You can read in this page how everything works, but I'll use a shortcut that I have on my slides. I'll simply use my shortcut here. So meanwhile, before I move on to actually demo what I will want to show, let's continue with this picture. So like I mentioned, we ask ourselves how to automate the process that's happening between writing source code and having a productive deployment. And I already mentioned Jenkins, and I showed the configuration as code. And now we were at the point where we care about the infrastructure, and we try to prepare infrastructure. All right, and like I mentioned, I want to use Docker on my local machine to run a Jenkins server. Once I have configured this on my local machine, I'm able to run the Jenkins server on any server that's capable of running Docker containers. To do so, I'll issue 2 commands on my command line, and I already showed you the repository and the documentation link. I have it also here on my slides, so once you get the slides, you can also use this shortcut here, which is also taking me to Project Piper, like mentioned, to the guided tour. Of course, you can also first click GitHub, then go to the title page of Project Piper, which is this one here, and browse the pages. And after a while, you'll find this page here, getting started with Project Piper. And if we scroll down a little bit, we see these commands here, which are used to install the CX server lifecycle management for Jenkins. I don't want to explain in much detail what these commands do, but very high levelly explained, we use Docker to construct a container, and after that we run it. And this container contains a Jenkins instance and exposes the Jenkins instance that's running inside of the container to my local machine. If I run these 2 commands, let's see what happens. For this, I'm moving one directory up because I don't want to create files in my my app directory, which is my Node.js application. So that I'll run the 2 Docker commands here. Okay, like we see, I've already run this command on my machine, so not very much happens here. But if you run it for the first time, you'll probably see something like this, which is a quite common Docker output. And at some point of time, it will finish and say, execute CX server help command to know more about the CX server script. And once this is finished, we run the second command, which is on the next slide. So we don't run CX server help. We might run it to learn more, but if we want to simply start a server, then we actually can do so by issuing this start command. And this is what I will do now, which is also here. I'm just copy pasting it. And this is something that's noteworthy. Docker asks me if I'm sure that I want to reserve that much memory for this, which might go up to 4 gig, like it states here. I'll say yes. And what's happening now is Docker will run my container with the Jenkins server inside of it. While this is running, I'll switch back to the slide where we see a condensed version of the output. We see here that we are also able to provide parameters for this. So if I only issue CX server start, I am using the default parameters, which are displayed here, but I can also provide some parameters to this script from the outside. So for example, if I don't want to run on port 80, but on another port, or if I want to configure the home directory or many other things. But for now, we'll stay with the default. Here we see the output that I just showed on the slide. And now we see that we are waiting for CX server to start, which might be ready in a second. Yeah. Having a look at this line, we see what happens inside of the container. We're running a Jenkins server, and we expose port 80. And actually, right now, when this is running, so we see that it set success. Now I have the Docker instance, the Docker container running the Jenkins instance on my local machine. And if I invoke localhost on port 80, which I can simply skip here, then I'll hopefully see the Jenkins instance. Yeah. And this is the second part for my continuous delivery pipeline. Just to remind you, we have the first part, which is configuration as code, which is here in our source code repository. And now we also have the infrastructure for this. What's missing here is to make everything run. For time reasons, I won't do this now, but as you probably know, Jenkins has a GitHub plugin. So if I create a multi-branch pipeline here and provide my GitHub credentials, where I committed my project, where I pushed my project, then Jenkins will automatically read and attach itself to this GitHub repository. What's noteworthy here is that this Jenkins is already equipped with all plugins that are needed to run the pipeline, which means that if we see this picture here, back to the slides. If we go one step forward, this is our desired production setup. So we are writing code on the left side, we are pushing it somewhere to GitHub, for example, then continuous delivery pipeline runs inside of our Jenkins instance, and finally does a deployment to the cloud so that we have to operate it afterwards. And you see that it's a quite complicated pipeline here. It has a lot of different steps for different types of testing, for compliance testing, static code checks, and many other things. Also, of course, zero time deployments. And in order to get all of this running, we need a bunch of Jenkins plugins that are already available in this Jenkins instance that I've just created here on my local machine. And like mentioned, since this is running in Docker, I'm now able to run this Jenkins instance anywhere. This is the idea how to get to this picture. What we saw so far is that on the left-hand side, we have the program code, the business logic, for example, where we use the Cloud SDK for JavaScript. We use the CLI to generate the project. And now as the next step, we could use the OData client libraries to access S/4HANA, for example, and build some business logic in there. And then we would push our code to GitHub, which will automatically trigger our Jenkins continuous delivery pipeline, which is powered by the SAP Cloud SDK for continuous delivery. And after that, this pipeline would deploy to the SAP Cloud Platform, which will happen in zero downtime, which is already built into the pipeline. And this is a very strong setup to prepare for production. So once you have this setup, you can concentrate on writing the business logic and on the business process. And in terms of the pipeline, you can concentrate on the content of every check, but not on the skeleton of and of the management of all the different checks. And like you see here, the pipeline will tell you exactly what fails if something fails. So this is a very strong benefit when starting development. Having said this, I want to conclude my demo and move on with this slide. If you want to learn more about the SAP Cloud SDK, we have different channels for that. Of course, you can start with our community page, but we also provide an open SAP course, and we have written a lot of tutorials where you can try things out. You can also use the recording of this video if you want to bootstrap an Node.js application and get hands-on the SAP Cloud Platform. If you are interested in the extensibility topics, like for example, extending S/4HANA, you can have a look at the book here. And if you decide to buy the book, you can you feel free to use this 15% coupon here. And of course, feel free to contact us for any topics that are related to Cloud SDK or extensibility topics on our email address or by commenting on any of the other channels. All right, this will conclude today's session from my side. I'll open up for questions, and for that I'll need to switch to the other window. But before that, I want to thank you for your time and for your attention, and see you in the next session. All right, let's see the chat window. Some questions.
Jordan, you have one in the Q&A tab.
Yeah, just trying to open it. Can you help me, Moshe? I cannot see the question.
Yes, no problem. Is there a schedule for support for OData v4 being available on SAP Cloud SDK for JavaScript?
We cannot promise a release date. We are evaluating it. It's a little more complicated than for Java. That's why we started with a release for Java, where we learn what is needed by our users. And probably we will also work on the JavaScript side, but right now I cannot promise a timeline for that.
Thank you. Do we have any other questions? Okay, so Jordan, I would like to thank you for this call today. The recording will be available in the SAP Community Call page together with the presentation.
Thank you too. And feel free to try out everything and to contact if something is not working as expected.
Thank you.